Okay, here we have some practice problems over multiplying matrices. We're going to look at these 5 matrices, give the order of the 5 matrices first, and then decide if these product matrices exist, and if they do, what size they would be. After you've done all that, go ahead and answer questions 7 through 11 as well, and then turn the video back on and check to see if your answers match mine. Okay, let's go in and look at this. Make sure that you assign the correct order to each of the 5 matrices. And then when you think about the order of the product matrix, you're making sure that those inner values match, and then the size of the product will be the outer values. So the only of these, one of these 6 that doesn't exist is A times C, because A is a 2 by 1 and C is a 2 by 2. Those inner numbers do not match. Okay, number 7. Does D times C equal C and C times D equal C? Well, that's just odd. Why would that be? I said yes. What is the special thing about these products that cause this to happen? Because remember, we said that matrix multiplication is not commutative, that order does matter. So what about this situation makes that not apply? Well, this is true because of the special nature of matrix D. Matrix D is the identity matrix, and our identity matrix is like our multiplicative identity. It's like multiplying times 1. So it is like multiplying matrix C times 1, and with that case, order is not going to matter. Because D is the identity matrix, we have a special case here. Then we get to number 8. We said no, that C times E is not equal to E times C. Well, look at C and E. They're both 2 by 2 matrices, which means the products can both be found. C times E and E times C can both be found. And those will both be 2 by 2 product matrices. But because the order changes, and matrix multiplication is not commutative, and neither of these 2 matrices is the identity matrix, that is not going to be equal. So CE does not equal EC because matrix multiplication is not commutative. We don't have a special case. Neither of our matrices is the identity matrix, so that is not commutative. All right, 9 asked us to determine if this is true, if the product BC is equal to this matrix 50, 66. Well, look at B and C. First, determine if I can find that product, and I can. Those inner numbers match, so the size will be a 1 by 2, 1 row, 2 columns. Well, that looks good. We've got 1 row and 2 columns. So now we just need to fill in values to check if these are the correct values. When I fill in the arithmetic, I get 14 plus 36, which is 50, and 21 plus 45, which is 66. So that is true. Now, number 10, I gave you a hint. I said, yes, product matrix AB is going to be this particular 2 by 2 matrix. And I set it up, but I didn't finish filling it in. So let's fill that in together. If I look at A, I'm going across A for the row. Row 1 has just a 1 in it. Row 2 has a 6 in it. And then I move down B to get the values in the columns. For B, column 1 has a 7, and column 2 has a 9, which gives me 7, 9, 42, and 54. Then I'm asked to find the product B times A. Well, let's see if that works, and if it works, what size it's going to be by rewriting them in the correct order. Remember, that's important. That's your first step always when you're trying to find a product matrix, is write the matrices in the right order. So I'm going to start with matrix B. Matrix B is 7, 9. That's a 1 by 2. And then I've got matrix A, and matrix A is 1, 6, and that's a 2 by 1. Because those inner values match, the product is going to work. And the size of the product is going to be a 1 by 1. So BA is going to be a 1 by 1 product matrix. So I look at the value in the row in B, 7 and 9. So 7 times plus 9 times. And then I go down that column in A, 1, 6, to figure out the value of that product. Well, 7 plus 54 gives me a product of 61. So BA is the product, that 1 by 1 matrix with the element 61. Okay, let's look at the next page of this practice. I give you 4 more matrices and it asks you to find 6 different products. Not all of those products are possible. So right off the bat, I want you to fill in the orders of the matrices and determine which of these products are not possible. Okay, hopefully your orders of your matrices match mine. And you just discovered that these first 3 are not possible. If I try A times B, those middle numbers do not match. When I turn it around and try B times A, B is a 2 by 1, A is a 2 by 1, those middle numbers still don't match. When I set up to do A times C, that would be a 2 by 1 times a 2 by 2, my numbers do not match. These 3 though work. C times A, C is a 2 by 2, and A is a 2 by 1. Those middle numbers match, so the size of that product is going to be a 2 by 1. And then CD and DC are both 2 by 2, so I definitely can do those. So these 3 problems are really the only 3 you have to work out. I'm going to go ahead and start by just giving you the values of those product matrices that you should find. And I want to encourage you to check and to see if you can get these correct values. I'm going to pause my video. I'm going to work these 3 out so that I can show you a key for them. I'm not going to talk through the key, but I am going to show you the key so that hopefully you can follow your steps and see if you missed something where you went wrong. So you pause your video, I'll pause mine, and I will work out these 3 products while you do yours. Okay, here I have the work part for 4, 5, and 6. On number 4, you're finding the product CA. So you want to make sure you have your matrices listed in that order. You get the values in the rows from C, the values in the column from A. That is what the work should be. When you do that arithmetic, you get the solution matrix, 1438. 5 and 6 both work with the same 2 matrices, but you have to make sure that you approach them in the correct order to get the right answer. If you're doing C times D, your rows come from C and your columns come from D. If you're doing DC, your rows come from D and your columns come from C. So make sure that you compare your work to those to ensure that you get the correct products.